Hello my friend, welcome to my game dev channel. My name is Alex and in today's video I wanna show you how to create interesting realistic ballistics in your game. What is ballistics? Ballistics is moving of object by specific curved trajectory, ballistic trajectory. Okay, I suppose you understand it. Now let's see what we'll achieve. Let's start the game. As you can see, I has invisible character, and let's see what we'll achieve. When I press left mouse button, my bullet flies. As you can see, my bullet flies by ballistic trajectory. Deceleration works as well on the distance because of air, and energy of my bullet loses in each frame. Depends on different forces. So let's see how it works with the other objects, because it's not interesting to shoot in the air, of course. And as you can see here, I have some blocks, several blocks, like wooden blocks and concrete blocks. Here is the tiniest wooden block. If I shoot something somewhere, as you can see, I had bullet holes here. And as you can see, my bullet changes its direction each time it penetrates the block and loses the energy, but not too much. As you can see, the energy is really high when it flies through the last tiny block, and then bullet just continue to fly. But what if I want to penetrate some widened block? Let's shoot here at the same point. As you can see, bullet loses much more energy because block is widened and because it's harder to penetrate this block for bullet. Moreover, it changes the direction each time when it penetrates the block, depending on different parameters of my bullet. The last block is just the widest wooden block you can imagine in game, just like a wall, for example. And as you can see, bullet penetrates first block, but when then they penetrate the second block, but then bullet just jumps because of losing energy. There is no much energy to penetrate this block, so it just ricochet back. Let's see it again. Oh, that time this bullet penetrates this block, but it's random, of course. As you can see, in this direction, when I try to shoot a bit higher, bullet even can't penetrate this block by this angle. So let's try to shoot straight. And okay, it penetrates this block. But then lost all its energy and begin jumping. Let's try to shoot through the concrete, the tiniest block. As you can see, we lost almost all the energy. Not too much energy is enough to kill someone. But what about second block type? And as you can see here, bullet actually lost almost all the energy and begin jumping in a couple of meters out of the last concrete block. What about the last type? As you can see here, bullet even can't penetrate the first block because it's too wide and too hard. What about ricochets? We can ricochet from ground, we can ricochet from concrete, we can ricochet even from wood in some angles. What about multiple ricochets? Let's try to achieve something interesting. Something like this, or even like this. And as you can see, bullet penetrates 3 or even 4 times and just lost all the energy. Looks nice, isn't it? What is more interesting about this system is that the system made from scratch. We didn't use any of basic projectiles, okay? We made our own projectile component based on line trace. Why line trace? Because line trace gives us a lot of information, much more than just a projectile in Unreal Engine 4 basic templates. Let's see how it works. As you can see, I had only one folder. In this folder I had some stupid material which I can delete because I don't use it. I had some some similar physical assets here. Let's open one of them. The other is the same, are the same. I didn't change anything. I just create physical asset, like type in. Don't type in, just press right mouse button here. Looking for physics and physical asset. Not physical asset. I am idiot. Sorry. Maybe miscellaneous. I even forget when I get it. Physical material. Yes. Physical material. Select. Create. And as you can see, this is the same thing. This is just the physical material. If I want to apply it for my mesh, I click on mesh, click on its material, and set my physical material here. The other interesting thing is bullet hole. It's just a material and a texture. Texture is just a texture of bullet hole with transparent field on the background, and bullet hole decal is just a material with such parameters, different decal, translucent, I suppose that's all, and texture sample, which is our bullet hole. That's all. Let's open our data. Data is more interesting because we have to create structure. To create structure, press right mouse button here, blueprints, and choose structure. Then add some variables here. In my case, 6 variables. I had 6 variables. Joules per centimeter, mean velocity to penetrate, the other parameters, just copy paste it. All of them are float parameters. And then you can open your Excel, like such a good table manager, and here you can create something like this. Using this structure, you can create 6 columns, exclusive role name column, and in role name column you have to create concrete, ground, iron, wood rows with different values on it. Values can be different, can be random, can be any, because it's not too important what values you put here. Just give some, I will give you some experience on choosing some custom values you want. You couldn't copy it. Okay. Let's open our actor. This is just an actor with name bullet, empty actor. We have nothing here, as you can see. But in our viewport, we have to add our mesh. In my case, this is sphere with some golden material, I suppose. Not tall, I even don't have this sphere, but you can do it. or just add your custom bullet mesh, and of course add our blueprint component which we create. Let's create blueprint component. You can type, press right mouse button here and choose blueprint class, actor component, and name it like me, BPC custom projectile, for example. Let's open it. Custom projectile is a really interesting thing because here we have all our logic for the bullet. Of course, many of these nodes better to create in C++ or even calculate out of the game, for example in Excel, because in Excel you can create some formulas, calculate different values, and just create one multiplicator instead of doing all these calculations during the game. This is just much more optimized. Or even you can create curve instead of this and choose these values you want, that values you want. Okay. In our event graph, we had such long spaghetti, but let's see. First of all, on event begin play, we get our velocity from the actor. As you can see, get owner means get owner of this actor component, in our case bullet actor. We get actor forward vector multiplied by speed. Speed is our local variable, bullet params, as you can see, bullet speed. Remember that in Unreal Engine all these parameters are in centimeters, so if you want to achieve something like 750 meters per second, you have to multiply 750 by 100. As you can see, 75,000 centimeters per second means 750 meters per second. Okay, then we get start position. Start position is just the position of the actor. The actor will spawn in your muzzle, flash socket, or if you add some invisible box to the muzzle of your weapon mesh, in your weapon mesh actor component, or actor, just actor, you will spawn our bullet just in here, and then you get this position in the first frame, on the first frame. Then we set our bullet as initialized and starting the delay with bullet lifespan, like 8 seconds. Bullet will live only 8 seconds. Then after this delay is gone, we destroy the actor. Okay, let's see more interesting stuff. Event tick. Here, if the bullet is initialized, our event tick works, and we set our delta seconds in the variable. Just for convenience, you can drag this line from here like this. Then we set our start position, also just get actor location of our bullet actor, and then we calculate our last position. How to calculate last position? We get our start position, add the vector, and the vector is the velocity multiplied by delta time. That means that if, for example, start position was here, then during the time and velocity, for example, velocity equals 1000, bullet flies in time 1000, 2000, 3000 per second, for example. This is the last position. So, okay, we get it. Then we try to draw line trace by channel here. And don't look at this make array just right now. We will describe it a bit later. Then I here have some debugging lines. You can just remove them or don't copy them. You can forget about them. Moreover, what is interesting, if something breaks our vector, something breaks our line trace, we have to get out hit variable here, just for convenience, then check whether to penetrate. To check it, we have to put two arguments here, like velocity and our out hit. Let's open this function. And whether to penetrate, how it works. We get data table row from our physical material, get object name, and get data table row for it. Then out row we break penetration data and make some calculations. So first of all, we have to calculate if velocity gradient multiplied by, don't if, just multiply the velocity gradient for our penetration data by velocity vector length. Then add velocity z-intercept and clamp it between 0 and 1 and multiply it by a clamped value of sum between impact angle z-intercept and multiplication of impact angle gradient and our calculation here. Then multiply both of these clamps and compare it with random value. If this value will be more than value between 0 and 1, and also if the velocity divided by velocity and the speed, current speed of our bullet divided by bullet speed to get the coefficient, as you can understand, more than our mean velocity to penetrate, we can return true, otherwise false. What the calculation is here? We try to get the angle between two vectors. The first vector is the vector of impact normal multiplied by -1 and normalized velocity. How to see? Let me a second. So as you can see here, we get our velocity. Velocity is a red line. We get this vector. And we get the normal multiplied by -1, just for convenience. And we get the angle between this normal and the velocity. And if this angle, then we manipulate with this angle. We have impact angle gradient. So if here we get some values like 45 or 90, after we multiply it by impact angle gradient, we will get something like 0.45, 1.12, -1.12, and so on. Then we add our impact angle z-intercept and clamp this value. Multiply them by this stuff and compare with the value between 0 and 1. This is just for randomness, because we understand that even if the angle is big enough, penetration sometimes happens, okay? And this is something like this. we want to penetrate in some cases. Most of the time it will ricochet, but sometimes it will penetrate. And also we can check if our velocity is enough to penetrate this object. Because if we lost almost all the energy, almost all the velocity, how can we penetrate the object? Okay. In many cases, if we remove this bunch of code, bullet will just ricochet back. But we want to penetrate, but not through the object. Our bullet should stack inside the object. I suppose you understand what I mean. Let's remove this print string. Okay. Come back to event graph. Whether to penetrate. If we can penetrate the object, we spawn bullet hole, spawn decal at location, set fade screen size, just to make sure that our bullet hole will be visible even far enough from the wall. Decal lifespan equals 20 seconds. Then we have to compute exit location. Because bullet stuck, okay, but we want to penetrate, for example. We get velocity, normalize it. Normalize means something like clamp, but all values will be in the range of -0 to 1. Okay, I suppose it makes sense. Compute exit location. Here we have some interesting stuff. We get actor bounce. Then we get the maximum value of it, multiplied by 4. We can multiply it by 2, but to make sure, we multiply it by 4. Set our trace distance. But before, what do this get actor bounce? What do? Interesting question. Get actor bounce, of course. But why we want it? Because we want to make sure that our bullet even can penetrate this object, because object can be tiny, can be widened. We want to understand it. Then we can set our trace start location, get impact point, and add our direction multiplied by trace distance. Direction is, let me show you where it is, direction. Let me 1 second, please. Direction is our compute exit location, is our input, our argument, which is velocity multiplied by normalized method, and we get the direction. Okay, then trace start, add our direction multiplied by trace distance -1, because we want to get this point, let's see in the picture. So I suppose it makes sense, but here, as you can see, red line is our bullet. Stuck in our object. We get actor bounce, which is the yellow line, multiplied by 4 to get, and get trace distance multiplied by direction. Direction is here, and you can see we get this start point. Then we multiply it by our impact value by -1 to get this, and by trace distance to get this trace back. We get this point, something like here, and draw the trace. When this trace breaks here, if this trace breaks here, we can spawn our bullet here, and it will move then in any direction from the other side of this block. Okay, I suppose it makes sense. Moreover, we have to check something to make sure that there is no other blocks in our trace, because, for example, if here there is another wall, our bullet will ignore this field between blocks and will go through the second block. Okay, so how to do it? Let's open. We make line trace. Then we check if we penetrate something, if we found our block again. We just check if this actor which we hit equals to the actor which we hit firstly. If it is, we add this actor to ignore list, because we want to penetrate maybe several blocks and we don't want to penetrate this block again. So we had this array ignore list, we add this to the ignore list, and then set our trace start again from the impact point. We don't spawn our projectile again, we just change our start point. Okay, I suppose it makes sense. And then we can line trace again, line trace again, line trace again. Okay. For example, everything is good. Compute exit location. We found the location. Then we check if the final velocity after we penetrate this object is more than 0, because if not, we should destroy our bullet. So if it is, we can add to the actor to ignorance, actor to ignore, our heated actor. Let's come back. Here is, as you see, I have make array method with added actor to ignore variable. As you can understand, when we penetrate this object, we have to add it to the ignore list, because we don't want to penetrate or do something with it again. Because when we spawn our bullet in the exit, it will immediately be immediately blocked by this object again if we don't do it here. Then we spawn bullet hole on the other side of our block, set actor location here, because we want to set our bullet actor from the other side of our penetrated block, and update velocity. Then we can vary trajectory, but let's firstly look at this function, vary trajectory. As you can see, or can't see because spaghetti fucks my brain, we have surface normal and impact velocity. We calculate the angle. Don't calculate the angle. No, we calculate the angle. Strict. Then we check if the angle is more or equal 90. We can update velocity and rotate our bullet. Make rotation by delta rotator from x vector, multiplied by 1 minus our angle divided by 90 to get normalized value, and then we rotate the vector and update the velocity. Otherwise, we just get the angle from here. Also here, to set this initial answer, set this vector variable, we get random unit vector in column in radians multiplied by our bullet speed, and here we get some map range clamped, as you can see. You can just copy, don't change anything here because it's just useless. You can, but don't do it. It works perfectly right now. Let's come back. Here, as you can see, we have the velocity variable, which we update before the right trajectory. And here we have the function compute gravity and deceleration. To compute it, we have to get velocity as argument, but before we can remove it. We should get velocity normalized. Direction multiplied by final velocity. Direction multiplied by final velocity is our current velocity. Current velocity added a bunch of code. Here we see that we have drag force for our deceleration, and this part of code better to calculate in Excel with the same formula but in Excel. And then we add gravity. You can also calculate it in Excel, but I recommend you to don't do it for gravity, because we want to change gravity in some cases. For example, if we're shooting in some unusual situations, like in space, for example, the gravity will equals not 10 or 9.8, but something else. So we add this gravity multiplicator and drag multiplicator to our z value of our vector, and our z vector multiplied by time, delta time, just event t delta time, and added to our current velocity equals our final velocity, which actually makes our curve trajectory. This part of code makes our curve trajectory. Let's see how this formula looks like. Here we see air density, which is actually a constant, but you can change it if you want, multiplied by bullet speed in square and multiplied by drag coefficient c, which is also some mistake here, I suppose. Maybe not, maybe just arguments names are not correct. Cross section multiplied by cross section multiplied by this is not really important, to be honest. Yeah, really not. We can even change it like such. So when we multiplied our air density by squared bullet speed and drag coefficient and cross section, we divided by 2 and multiply by -1 to get this down movement, because otherwise bullet will move up by curve. And here we have gravity, which is 9.8 multiplied by 100, because everything is centimeters, but not meters, and multiplied by mass. Just a simple formula of force. Force X was mg, just mg, or ma if you want, and multiply by -1 to get this downside direction. Okay. As you can see here, we did everything like we want. Now let's see what if we doesn't penetrate anything. We just update our vector location to the last position, and if it doesn't impact anything, we just don't look at this. It's just for draw debug line. We update our set vector location in our last position as our last position, and then just compute gravity and deceleration and set velocity. That's all. But what if we decided to not penetrate the object? If we want to ricochet our bullet, we have to compute ricochet from out hit. From out hit we get impact point and impact normal. We add them and get the start point. It is necessary because we don't want to be blocked by the object. So we want to start this ricochet a bit out of the object. But you can just get impact normal for it, or not impact point, but impact normal, but impact point. Here we have this function mirror vector by normal. It's just an Unreal Engine function. You can use it. Here we get the speed of our bullet. Decrease the speed divided by 2, just to update our speed each time it ricochets from object. So every time we ricochet, we lose half of the energy, half of the speed, and multiply it by our direction. So we get our current vector, current velocity, get the impact normal of it, and just return u velocity. Mirror makes just this easy stuff, like if we shoot like this, mirror will shoot like this. Okay, that's all for this function. Then we just add vector to ignorance again to make sure this object will not collide with our line trace. Then we set vector location, update velocity with compute gravity and deceleration function, and vary trajectory, of course, because even when we ricochet, we want to vary a bit our trajectory because velocity changes, because bullet is not an ideal object. So, and that's all. Just that's all. As you can see, after we compile all the stuff, we get something like here. Bullet can fly, loses its energy. Bullet can ricochet in a specific angle. Bullet loses its energy every time it penetrates it ricochet. Bullet can't penetrate some object and just stuck in them, and vector just destroy. Bullet right trajectory every time it penetrates the object. Bullet can penetrate several objects, and bullet changes its ballistic trajectory. Of course, if you will change some constants like air density, you can make sure that your bullet will fly in the middle. If you shoot in the middle of the display, the bullet will hit the object in the distance of 100 meters, just at the point you aimed on. I suppose it makes sense. For example, if I try to shoot in the center of the screen, bullet will penetrate 100 meters text just at this point which I aimed on. The same is for 200 meters. Bullet will be dropped a bit lower or higher. I don't see. So you can calibrate it by yourself. In future tutorials, I will show you how to calibrate scopes. So thank you for following me. Put likes, dislikes, ask me something in the comments. Stay with me. Thank you very much. Oops.